Okay, so let's put together a shear and moment diagram for this situation. This is much like the one that we talked about in the lecture, but now instead of applying a force at the middle of the beam, we're applying a moment. Okay, so step one, we have to determine the external support reactions. So let's draw a free body diagram here. And so I have a reaction at A and a reaction at B, and I have my moment here in the middle. So we'll just label these as reaction at B. Now, starting out, we can sit there and do a sum of the moments in the in the Y direction. Let's see what we've got. So sum of the moments, sum of the forces in the Y direction have to equal 0. Going to say downwards is positive. So negative RB minus RA minus RB equals 0. So that tells us that RA is going to be the negative of RB. So right off the bat, we know that one of these is drawn in the incorrect direction. And that's fine. So what I'm going to do is I'm going to sum the moments about point B. Counterclockwise is positive. We're going to say that's 0. So this is a free moment that just slides back and forth. It's counterclockwise. It's positive. RA is going to be rolling in the negative direction. And so that's going to be RA times this length is L. That's all going to equal 0. So the moment that we have there, and actually, we want to solve this for RA instead. So RA is going to be the moment divided by L. And let's actually call this MO, so the moment about point O, just to distinguish it from that moment that we're going to put together when we draw shear and moment diagrams. And so that tells me that RB, since we did the sum of the Y forces, is going to be negative MO over L. What does that mean? That means we drew that one's going to be our negative, this one's going to be our positive. Okay. Actually, quickly looking at this, RA is moving in the same direction as MO, so that should be positive. So that would make this negative, which would make this positive. Okay. Now, what does that tell me? Well, this is negative, which means that I drew this in the incorrect direction, which is fine. I'm going to redraw it over here, and the reason I want to redraw it in the correct direction is for when I do my shear and moment. So this is M out over L. Why is it negative? Why is it going in the positive direction? Because I drew it in the wrong direction over here. I'm not. And then this guy is positive, so it's going up, MO over L. So once again, I solved for this. Since this was negative, it told me that I drew this initially in the wrong direction, so I just flipped it in the other way. So there's step one. Okay, so step two is I want to identify every place that I have different things. So there's my beginning and the end. I only have one thing going on here. It's right in the middle. So that tells me that I'm going to have two separate sections. I have a section 1, I have a section 2. Because that equation is going to change once I add the moment to things. So let's do section 1 here. I want to do the sum of the forces in the Y direction. Those are going to have to equal to 0. And so let's draw the free body diagram. So that's at any x point up until that moment's applied. So I have M not L over here. And then when I get to here, I'm going to have a V and an M. I always draw those guys in the positive direction to start out with, and I let the signs figure themselves out as I go along. So some of the forces in the Y direction will be 0. So I have ML pointing downward. And then the only other Y I've got is that V, and that V is pointing in the positive direction. So that's plus V. That equals 0. So my shear force is going to be negative m naught over L. So there is my shear diagram. Now let's do the sum of the moments. Counterclockwise is positive. And we're going to do that about the free end here, so we don't have to worry about the influence of the shear. And so what I have is MOL times x, because that distance is going to be x to get it here to create a moment. And that's going to be going in the positive direction. My moment is going in the positive direction, so that's plus m. So I solve this for my moment, and what I'll end up with is negative m naught over L times x. So there are my two equations for section 1. So now we're going to do section 2, between that moment and the end. So let's draw a free body diagram of what's going on. So that's at any point from the moment being applied to right before we get to the end. So my free body diagram, what I will do is I will add that moment in. And then at the cut end, I'll have a shear and I will have a moment. Okay, first thing to do is we're going to sum the forces in the y direction equals 0. Remember, down is positive. So that force we have is m naught over L. And the only other force we have is plus V. So we go to solve it, and our shear force is going to be negative m naught over L, just like the one above it. Great. So now we'll do our sum of the moments about the cut end. Counterclockwise is positive. That's going to equal 0. And so what do I have? Well, from this one here, I have m naught over L times that x distance to get here. I have m naught, which is going in the counterclockwise, so the positive direction. And then I have m here. Oh, I'm sorry, that's going clockwise, so that's in the negative direction. This guy, m naught over L, is going in the counterclockwise direction, which is positive. And I have the internal moment, which is also positive. Okay, so now I go and I solve this for m. And so what I'm going to do is I'm going to bring the stuff to the other side. So I'll have m naught minus m naught over L times x. And what I can do is I can simplify this a little bit. One, we can pull the m naughts out. So m naught. And so what I'll be left with is 1 minus x over L. Okay, and so there's our moment equation. So before we plot these, we've got our shear forces are both straight constants. This is a negative linear line. This is also a negative linear line. So this is going to be interesting. We have two negative lines. Okay, so what I want to do is I want to keep this going. I'm going to open up a little bit of room here. So I'm going to get rid of some of our equations. I'm just going to erase them because we need to figure out where everything starts and stops. And so I'm going to need some room to do that. And there we go, that should be enough room. So let's start with our shear diagram. I've already got, so shear moment. There's my 0 axis for the shear. There's my axis for the moment. Shear diagram should be easy. We look at it from x equals 0 to x equals L over 2. It's just going to be negative m naught over L, no change. And then I look at section 2 from L over 2 to L. I've got negative m naught over L. Shear diagram is just a constant negative m naught over L. Okay, so let's look at section 1 at x equals 0. So I'm going to plug in 0 here for m naught over L. And once I do that, it should be easy. I just drop a 0 in. I know that's going to be 0. Our second point is that x is L over 2, because that's where this next section is. So if I drop an L over 2 in there, what am I going to get? Well, L over 2 over L. The L's will cancel. I'm going to be left with a moment of m naught over L. Actually, no, that's m naught over 2 because the l's cancel out, but there's also a negative sign in there. So I will have negative m naught over 2. And let's just quickly, m naught over L times L over 2, L's cancel, negative m naught over 2. So that's going to be here. And this is going to be negative m naught over 2. This is a negative linear equation, so that should make sense because we're going to go right there. And so there's the first part. Okay, so now let's go and let's look at equation 2, section 2. So that was section 1. Section 2. Section 2 is going to go to x equals L. It's all the way at the end. And so if I plug in L here, I get L over L, which is 1. 1 minus 1 is 0. So that tells me the moment's going to be 0. Now, before we've looked at it, we're going to go, oh, well, it's just going to start right there, but let's double check because that might not be right. So at x equals L over 2. So if I've got this, I'll just plug it right in. M naught 1 minus. So x is now L over 2 divided by L. Okay, and so now we can sit there and calculate this out. So what is L over 2 divided by L? That's going to be a half, because the L's are going to cancel, and then you're going to have 1 half left. So 1 minus 1 half is going to be a half. So what you're left with is positive m naught over 2. So m naught over 2, we know it's going to start here. It is going to be a negative equation again, so it's going to come down like that. And so there we've got the entirety of our moment diagram. So at L over 2, where we add the moment, we have a jump. And actually, if you look at it, we go from negative m naught over 2 to positive m naught over 2, which is a moment jump of exactly m naught. So that should kind of make sense. So one thing I do want to point out with doing these shear and moment diagrams, you really need to label the points. So we need to know what the maximum and minimum values are.